All right. So for example, that same compound, all right, let me just erase this part. So let's draw it back. So the carbon is slightly positive. That is slightly negative. So that means if I have a next one, right, let's put back the H's. There can be an attraction between the positive carbon and the negative fluorine. Right? So that attraction, that's the permanent dipole. All right, so you get permanent dipole. All right, let me put that.
Sir,
Yes.
but how does the carbon, the top one ever is the CH3, how does the carbon in that get a slightly positive charge? Is it like neutral or something?
No, were you here when I was explaining the case with oxygen and hydrogen?
Yes, sir.
It's the same thing. So remember carbon. So let's just look at carbon and fluorine. The electrons, when they share them, because fluorine is electronegative, so electronegativity is the ability of the atom to pull electrons towards itself. So because chlorine is very electronegative, the electrons will not be shared equally between carbon and fluorine. So what will happen, fluorine is going to pull the electrons closer towards itself. So it's because of this uneven or unequal sharing.
Come on, nice take around, it's a hot. Come on, guy, don't worry about me just send that game food. Place hot.
All right, let me continue now. Right, so it's because of this unequal sharing of electrons, right, where they are very closer to oxygen, sorry, fluorine, the fluorine develops a slightly negative charge. Now, carbon is electron deficient, so it gets the slightly positive charge. Sorry, replace. All right, so the person that asked the question, you understand now?
Yes, sir.
Yeah, man. So once you see, it's typically especially in these cases, you will typically get carbon and hydrogen bonded to an electronegative atom. So once you see carbon with group 5, 6, or 7, or hydrogen with group 5, 6, or 7 in the first row, so nitrogen, oxygen, fluorine, all right, every chlorine from the third row in the periodic table, it will be polar, all right? So if you want to make a list, these are the most popular ones. So fluorine, you have nitrogen, oxygen, and you can add chlorine to the mix, all right? So once you see hydrogen or carbon bonded to any of those, it is going to be polar, all right? So in this, when the molecule, so if you have a bond that is polar, we consider the entire molecule as, we just said the molecule is polar, all right? But you see, if this, I'm going to show you a little later with some other examples. So a molecule, depending on the size, it can be both polar and non-polar. So it can have a polar group, for example, like fats, where you have the carboxylic acid group, the COOH, that part is polar, but the rest of the hydrocarbon tail is non-polar. And we will see how that affects it acting as a solvent. All right, but for now, permanent dipole, it occurs when you have an atom bonded to, you can add in covalent because these are all covalent compounds. So when you have an atom covalently bonded to an electronegative atom, right? So that is the starting of permanent dipoles. You must have an atom covalently bonded to an electronegative atom, right? So that the charge is or the electrons is unequally shared. All right, so that is what is causing the slightly negative and positive charges, the unequal sharing of electron, and that will only come about because of one of the atoms being highly electronegative. All right, so CH3F, that would be permanent dipole. All right, so let me erase this with water and continue. All right, so let me see, where was I? All right, so an atom is bonded to an electronegative. An atom is bonded to an electronegative. You should have atom right here as well. So an atom is bonded to an electronegative atom in a compound. This same thing happens in a second compound. All right, so that is the example here. So carbon is bonded to an electronegative atom. The same thing happens, all right? So let's do that. So, well, it's basically here. So the same thing happens in a second compound. And finally, so the third point, so this is point 1, point 2, point 3. All right, so that is it. So again, I'm going to give you a minute, and then we look at Van der Waals forces, which is the same